Hey everyone, welcome. Today we're diving into the invisible architecture that powers our entire digital world. It's the secret sauce that stops the biggest apps we use every single day from just crashing under pressure. I mean, really think about it for a second. You open up an app, and at that very same moment, millions of other people are doing the exact same thing. And yet, it just works. So how does that happen? Well, it's not magic, I promise. It's all thanks to a crucial discipline called system design. And really, the best way to think about it is like a blueprint for a building. This is the master plan, the grand vision that defines the entire structure of a software system before a single line of code ever gets written. It's the key to making sure that what you build is efficient, organized, and can handle pretty much anything we throw at it. So let's stick with that blueprint idea. You would never, ever start building a skyscraper without one, right? And it's the exact same idea for a massive application. This blueprint for code usually comes in two main parts, and they look at the project from two totally different altitudes. First up, we have what's called the high-level design, or HLD for short. This is that 30,000-foot view. Think of it as the plan that the lead architects create. They're looking at the entire city block, not just the details of one single building. So the HLD isn't about the small stuff. It's all about the big foundational questions, like what are the major pieces of our system? How are they all going to talk to each other? What kind of database makes sense for what we're trying to do? In short, it defines the entire skeleton of the system. And here's a fantastic real-world example, Netflix. For a while, they had one single gigantic application, a monolith, and it just couldn't keep up with their crazy growth. So they made a massive, high-level decision to break it all apart into these smaller, independent microservices. This was huge. It was like tearing down one giant clunky mansion and building a whole campus of interconnected modern buildings instead. It let their teams move way faster and scale up like never before. Okay, so if HLD is the architect's grand vision, now we have to zoom way, way in. This is where we get to the builder's plan, or low-level design, LLD. If the HLD is the blueprint for the entire building, think of the LLD as the detailed wiring and plumbing diagram for just one single apartment inside it. The LLD, well, this is where you get into all the nitty-gritty details. It answers all the specific questions, like how exactly does this one feature work, step by step? What do our database tables look like down to the last column? And, what kind of error message should a user see if something goes wrong? This becomes the actual actionable plan for the developers writing the code. So, to put it simply, HLD defines the what, and LLD defines the how. One gives us that big picture structure, while the other gives us the super detailed implementation plan. And to build any complex system that actually works, you absolutely positively need both. But you might be wondering, why go through all this trouble? I mean, why create all these detailed blueprints? Well, it's because they're designed to achieve some absolutely critical goals that prevent systems from just crumbling under pressure. First up, and this one is a giant, is scalability. Just imagine your new streaming show goes viral overnight, and suddenly 10 million people are trying to watch it at the exact same time. A scalable system is designed to handle that massive sudden spike in traffic without even breaking a sweat. It just works, giving everyone a smooth experience. Next, we have performance, which, let's be honest, is all about speed. When you click that play button, how long do you have to stare at a loading screen before your video starts? That delay is called latency. And a well-designed system works obsessively to minimize it, to give you that instant responsive feel. And finally, there's reliability. Put simply, we just expect the system to be there and to work correctly. It should be running 24/7 with as little downtime as possible. And good system design does this by building in backups or redundancy, so if one part fails, another one can take over instantly, and you, the user, never even notice. Let's circle back to that scalability thing for a second. When you need to handle more users, you have two main options. The first is vertical scaling. That's like taking your one server and upgrading it into a supercomputer. The other option is horizontal scaling, which is like adding more and more standard servers to your team and just splitting the work between them. And pretty much all the huge systems like Google or Amazon, they rely heavily on horizontal scaling. Okay, so how do you actually start to think this way? How can you begin to tackle problems with a system design mindset? The good news is, it's a structured process. It's not some random burst of genius inspiration.
It always starts with truly understanding the problem you're trying to solve.
From there, you can start to sketch out that high-level architecture and pick the right tools for the job. Only then do you start breaking it down into smaller pieces. And maybe the most important part, you have to plan for growth and scalability right from day one, not as some panicked afterthought when things are already breaking. So let's leave you with a little challenge. If you're sitting down to design a simple ride-sharing app, what would be your first big decision? Would you start with a low-level detail, like choosing the specific database? Or would you start with a high-level decision, like defining the main services? One for riders, one for drivers, one for matching them up. Answering that question, well, that's the very core of thinking like a system designer. Thanks so much for joining me.